Hello everyone, and welcome to episode 3 of my Minecraft modding workshop lessons. So today we're focusing on lifecycle, blocks, and data, which includes tags, loops, tables, and recipes. If you don't know me, I'm Kat. I'm a 4th year cybersecurity major. I say this every time. I've done modding for like 8 years. And yeah, have fun, follow along if you want. We're gonna talk about some stuff today. So the first thing we're gonna talk about is the life cycle of the game. So this is how mods initialize and how that works in relation to the game itself. So there are 4 main phases of the game life cycle. First, you have bootstrapping. So bootstrapping is the process in which the mod launcher, so it like the very first piece of code that runs in the game's runtime, it's usually getting replaced by the mod loader itself, decides how to identify like what jars to include and transform the game's runtime to be compatible with mods. It also applies access transformers and mixins at this stage. And then the second stage is initialization, which that's when mods actually register their content and deal with configs, interact with other mods. That's when the game is actually starting, and that's when most of what mods do actually happens. And then you have level initialization, which is when you actually open a world. So on dedicated servers, that's like the only thing it does like immediately after the game starts. But on single player, you can like open the menus, go to multiplayer, that sort of thing. And then you have shutdown, which on the client, that's when it goes back to the main menu. On a dedicated server, it just closes. So a little bit more about the bootstrapping phase. I've talked a little bit about how mod loaders work, but this is a little bit more in depth of what the actual like software is doing. So first you have like the bootstrapper loads. So that would be on Forge and NeoForge. They use MC Mod Launcher, and then NeoForge uses Fancy Mod Loader, which is just a renamed version of Forge Mod Loader, which is used on Forge. So the Forges are a little weird because they split this functionality into 2 different things. So Forge Mod or FML does like the actual loading the mod jars and stuff, but MC Mod Launcher acts as like a plugin that Forge Mod Loader hooks into, and MC Mod Launcher also does like the remapping stage and opening Minecraft stage. And then Fabric just uses Fabric Loader. And so the game collects all the mods that are in the mods folder and checks them to make sure that they have their dependencies met, and that they can reference each other by like adding them into the JVM's like runtime on the class path is what it's called. It transforms those mod jars to actually meet the runtime obfuscation mappings and transforms the game itself. It loads and transforms any game libraries, which are like jars that contain references to Minecraft code but aren't actually mods. It transforms those to make sure they work with the game. And it checks it checks all the dependencies. And then it also prepares Minecraft itself for launch. So it's like providing the right startup arguments, applying the core mods, mixins, access transformers, updating the mappings of the game. So on Forge and NeoForge at runtime, the game gets transforms to Moj maps or official mappings, Mojang mappings. And it does that at install time. So when you use the Forge installer, it replaces the jar with a new one that's remapped. And on Fabric at runtime, it transforms to Intermediary, which is Fabric's intermediary mapping system. And it does that at runtime on the first run, but then saves the result. And some loaders also have like pre-launch events and configs, which mean like you can run code during the bootstrapping phase, but it's not used very often because it's so like low level, and most mods don't need anything to do with that. And then you have the initialization phase. So in the initialization phase, all the mods have been started and they start constructing and registering their content. The game starts loading assets, and things start happening within the game itself. And so the thing to know about initialization is that there's literally no guarantee of the order in which mods initialize or what their initialization having happened means. So like on Forge, if you go to the like post initialization stage and you check if a mod has initialized, that doesn't mean the mod has already registered literally everything in it. You have no idea. So that's an important thing to know. It can happen in parallel, which means it's put on worker threads that run at the same time concurrently. So yeah, no order. If you try and rely on other mods during your own initialization phase, then you can have like race conditions and stuff. The initialization process in Forge and NeoForge looks like that on the right. So first you have the mod classes get initialized, and then the registry events fire, common setup fires, the sided setup events fire, and then intermod comms, which is an event system that lets mods actually communicate with each other, fires. So that's split into 2 phases. You can do sending message and then processing messages. And then finally, the load complete event is fired. So all the Forge lifecycle events start with FML. So FML common setup, FML load complete. And then on Fabric, the initialization process is a little simpler because it's not like the same amount of parallel. It doesn't try and do it all at the same time. So first, it just fires your mod initializers, and then it fires your sided initializer. And then Fabric, rather than using intermod comms, uses things called mod entry points, which let you determine if an entry point will fire based on another mod like being loaded. And that means you can like interact with the code optionally, because the entry point, the mod entry point, won't get loaded at all unless that mod is loaded. So there's no like class loading errors that will happen there. And then yeah, so a little bit more about Forge's parallel initialization. Because it runs on a worker thread, as in it's not the main common thread, you can't interact with the game itself, like the game's code directly, because it will trigger like concurrency errors. So you have to unqueue that work into the main thread. So you can do that using the unqueue work method on the event object, which lets you pass lambdas to it to execute on the main thread. And then after that, the server initialization phase, or the level initialization. So this is when you actually click on a world and begin to like load into a world. So the first thing that happens is the main thread starts attempting to initialize the server because you clicked on the world. Or if you're on a dedicated server, it's just starting. And then Datapacks load. So Datapacks are per world. I'm going to talk about Datapacks later in this lesson, but you can vary them based on the world. And then the Minecraft server instance gets created. Minecraft server is a class in the game, and then starts executing its initialization code. And then right in those initialization functions, Forge starts loading its server configurations, which are per world configurations. So anything that's not like a common or client configuration, those get loaded during the game initialization phase. And then after those server configurations load, Forge fires the server about to start event. So this is all for Forge. Fabric is a little bit of a simplified because it doesn't have a config system, so it doesn't like the distinction doesn't matter. And then the level itself begins loading, so you'll see like the world is loading screen, progress bar sort of thing. And the levels fire load events when they're loading, and then at the same time, this is parallel, the server starting event fires. So there's no guarantee of the order there. Those both fire arbitrarily at the same time. And then once all the levels finish loading, the server started event fires, and then after server started event fires, the server itself starts like ticking, which means it's actually running. And then I put the order of those events below there. So load server config, server about to start, levels start loading, server starting event, levels finish loading, and then server started event, and then the server starts. On Fabric, you have the server starting event, levels finish loading, and then server started. So they don't have the about to start event in the same capacity. And then you also have the data pack events, which lets you hook into that part. Forge has the same, it's just, I didn't note those down. So that's Lifecycle. Now we're gonna talk about blocks. Guys, it's Minecraft. What does Minecraft have, but what did I just do? What does Minecraft have but blocks? So a little bit about blocks in Minecraft. They have a type, which is their ID, which controls their like fundamental behavior, so how they react in terms of other things, their states, that sort of thing. Blocks can have states, which allow them to change between a bunch of finite like sets statuses, and that can adjust the behavior of the block, the appearance of the block, and they can store small amounts of data. And they also have a voxel shape, which is a class that makes like hitboxes for things. So you can have custom hitboxes on blocks. That's how things like torches, like you have to actually click on the torch square itself rather than being the size of the whole block, even though its model is like, that's what makes the shape conform to the model. You have to actually define those. And then like items, blocks are also flyweights, which means there's only one instance for each type of block. Because, I mean, if you really think about it, if you had all the blocks in a Minecraft world and every single block had a new instance of the block class, and then how much memory would that take up? That would take up a ridiculous amount of memory. So, yeah, blocks are just one. There's just one. Some blocks can have multiple parts, like doors and beds. So those are two different blocks that have their own states, and they react to each other's existence. And then block items, which I think I mentioned last week, they're items that place blocks. So any block that you place probably has a block item associated with it, which is actually an item. Like, it's a real item. It's registered the same as any other item. Works like any other item. But they share an ID with a block, and they're an instance of the block item class, which means you can define behaviors for how it's placed. So when you right-click that item onto something, it places a block. It's just a special type of item. So not all of them look exactly like their block or correspond directly to one certain type of block. So like signs, for example, you can place those. They don't look like it. I'm sure, like, not every block item is exactly the same. Like, what's up?
I was going to ask if chests or like any blocks that store items.
Yes, we'll get there. We'll get there. So multi-part blocks can use additional logic to like place the two blocks at the same time. So like a door that places two block states at the same time when you right-click on the ground, and it has its own like placement logic to determine that like it's a valid location. And some blocks are like reactive to your facing direction, like signs, and they change the block state that you're placing based on that. And then you have block states. So block states store the actual data associated with a block for the most part. We'll get there. Similar to an item stack. So each block state is still like each instance of the block state class. There's only one per unique state per unique block. So like for each facing direction of a sign, there is one block state that corresponds to that for all signs of that type. Because also if you had a million block states, that would be too much memory. They exist for each location in the world, and they consist of finite immutable states, which means that you have a limited set of states that you can have for a given block that it can be in, and they're predefined. You define them before the game starts. There's usually not more than 128. There's no actual hard limit. They removed that, but generally, if you can't contain it within a couple, within 100 or 200 states, you should not be putting it in a block state. So examples of states, you have facing direction, if something's waterlogged, the amount of bites you've taken from a cake, what the growth level of wheat, your redstone status, if you're active redstone wise. And in terms of the block state class itself, you don't actually use blocks, like the block class within the game very often. Most of what the game passes around are block states. So because they actually contain the data associated with the block. And block states can vary the behavior of blocks a lot. So most things are passed through block states. What you'll also find is that the block class has methods on it, like get, shape, and then the block state class will have the same thing, but it just proxies the blocks method. So when you're interacting with it, you use the block state method, but on the block itself, you override the method because you can't actually override block states. So a little bit more block states. Each unique combination of your block state has to be mapped into the model variant class. So that's the model variant JSON. So that's, like I mentioned in last week's lesson, in assets, there's the block states folder. So you define which models correspond to each block state there. Block states have multiple properties, or can have multiple properties. So each property is a different collection of states. So facing and waterlogged are both properties. So you can have both on the same block, and because there's like combinations happening here, you have potential to create a lot of different states just by adding different like properties to it. So if you have waterlogged yes or no, and then you also have 4 facing directions, that's already 8 block states. Blocks can have default block states, which they spawn as, and then at the bottom there, that's the format which block states look like when denoted as text. So you'll see that a lot in like asset definitions, and if you're like doing /set block, you would denote it like that. And then so block entities are a concept that we will go deeper into in later lessons, but I just want to introduce them. So if a block state can't actually contain the data you need, like for a chest or a sign, like the text on a sign, like if the data is arbitrary or there's a large amount of it that could be like theoretically infinite, unique, you need a block entity, which is a special type of thing that's tied to a location in the world. It can store data and it's associated with a block. They can also tick, which means that like the game can actually have them run code every tick, rather than just being like inactive, not doing it. Most blocks don't actually do anything. They don't update every like interval. So furnaces tick, for example, to cook food. So they're used for things like furnaces, chests, and signs, which have a more active role and exist in a large number of different states. But something like pistons and doors, they aren't block entities, even though they're like very interactive and they do a lot of things in the game. They aren't block entities because they're not storing a bunch of different states. They don't tick. Everything they do can be contained inside of block states. And then a little bit about the different ways a block can tick. So you have block entity ticking, which I just described. And you also have random ticks. So random ticks are used to like randomly receive an update from the world at a random interval. So the speed of that, or not the speed, technically the volume, is adjusted by the random tick speed game rule, which you might be familiar with. It's used for things like crop growth or like grass growing, that sort of thing. So things that randomly spread or randomly update, they use as random ticks. So every time that a wheat receives a random tick, it has a chance to grow into the next stage. So the way it works is the game chooses some random blocks in every chunk that is currently active, which means it's nearby a player, and then runs their random tick method if they have it enabled. And then there's weather ticks, which are actually just a like they're technically chunk ticks. The chunk can perform weather ticks. So for active chunks, they will trigger a weather tick if there's rain or snow happening, which like makes the top block on the terrain do an update. And that update can do things like fill a cauldron and make snow on a surface. And then you have scheduled ticks, which a block actually schedules itself to update in a certain amount of time. So it's used by repeaters to add delay. And then you have animation or client ticks, which are used for things like spawning the torch particles and the furnace particles, and they fire more often the closer you are to something. So that's the ways a block can tick. And then also the concept of block updates is important. So you probably might have heard of this if you know anything about technical Minecraft, but blocks can receive and react to updates around them. So when you like place a block, it sends an update to adjacent blocks. That's called a neighbor change. There's different types of block updates. They have different ranges, like how far around things they affect and what they actually perform. So like if you place a fence, that fence updates its neighbors, and then those fences actually update their model to match the fences next to it. So that's all. It's also how redstone signal propagates between blocks, and it propagates instantaneously. Like it doesn't take time for those updates to pass. Like it doesn't take a tick for redstone to go from one redstone dust to another redstone dust. It's just runs. So and some blocks obviously add a delay there, like repeaters, observers. So observers are actually a really good example of this. They react directly to block updates. So if you trigger a block update, the observer can actually react to that and then trigger redstone. So yeah, and which neighbor actually updates depends on the type of block and the type of update that's occurring. And then now getting into like the actual block functionality. So these are like the block properties class is very similar to the item properties class. So it's the attributes passed to a block when it's constructed to make some like base behavior. So you can specify things like its light level, collisions, the time it takes to destroy, if it drops when using the wrong tool, explosion resistance, your walking speed adjustment like soul sand, if it's bouncy like a slime block, can it be replaced like tall grass? If you right click on tall grass with a block, it'll actually replace that tall grass with the block rather than trying to place around it. Its reaction to pistons, if it's liquid, if it receives random ticks, does it conduct redstone? Like is it solid for redstone purposes? And can entities spawn on it? So lots of things like that. There's more. So here's some like important methods in the block class. Modern Minecraft, actually, there's block, and then there's block behavior, which is like the actual base class, but there's no instances of block behavior. It just contains a lot of behavior related to blocks. So if you're looking at the block class and you're confused why there's nothing there, it's in block behavior. So you have create block state definition. This one is really important. You override this, and then it gives you a builder, and in that builder, you pass a list of properties and their possible values so that you can define the valid block states for a block. There's the asItem method, which gets the associated block item. You have the destroy methods, which can react to being destroyed. That's different from being removed. So destroyed means it was broken. Being removed means it was simply replaced with something else. So like if you use /set block, it doesn't trigger the destroy method because you didn't actually break it. I think there's a flag for whether you do that or not, but there's set placed by, which is triggered by block items when the block actually gets placed. And then the get shape methods, which you can adjust the shape of things there. And can survive is pretty important. So like for things like torches or signs, it determines if it's like a valid placement location in its current state. So the can survive method would fire on a block update. So like if you broke a wall that a torch was on, the block update would fire the can survive method on the sign itself. The sign would check to see if the wall it's on still exists, and if not, it destroys itself. More block methods, you have on place and on remove. So those are actually when they come to exist and when they are deleted. And then you have update shape, which is used by like fences to react to block updates from its neighbor. So different like block updates can correspond to different methods in the block class. If you look at the block update page that I think I linked on the presentation, it'll tell you the correspondence of different types of block updates to different methods on the block class. And then you have the use methods, like use without item and use item on, which react to being right-clicked on. You have random tick, which reacts to random ticks, but you have to enable those in the block properties. You have tick, which reacts to scheduled ticks. And then you have, and that's not like block entity ticks, only scheduled ticks. And then you have attack, which reacts to being like punched. So that's the lore on blocks. And I'm going to move into data. So data being the data pack concept in Minecraft. So like assets, they have this folder structure. It goes in source, main, resources, data instead of assets. Each subfolder corresponds to the namespace, same way as assets. And you can customize other mods the same way as assets. So your subfolders are tags, loot table, recipe, damage type, enchantment, advancement, structure, world gen, and there's more, but those are some important ones that are most commonly used, especially tags, loot tables, and recipes. Those are very common. And those also have subfolders. Tags recently changed like their plurality, same with loot tables. So in 120, it was loot_tables. In 121, it is loot_table. So that's an important distinction. And it also used to be tag/blocks. Now it's tag/block. So if you're confused by old code, it changed. So tags. I mentioned these briefly last week, but I'm going to go deep on tags now because they're important. Tags collect a group of items, blocks, entities, biomes, or literally any other type of registry object into generalized groups that the game can use. So they can be tied to behavior, crafting, a bunch of stuff. For example, if you have a tag called planks, it could include oak planks, spruce planks, all the different types of wood planks. And then you could use this planks tag inside a crafting recipe, like Minecraft uses it for sticks, so that you can use any type of wood plank rather than having to make a separate recipe for each type. And then there's also ones that like do things, so they like change how the game behaves. So you have freeze immune entity types, which means they're immune to the freezing effect from powdered snow or deep snow or whatever. And then you have the mineable ones, which like change how being mined by different tools, reacts. There's a bunch of different tags, so it's good to look through the tags page on the Minecraft wiki. And the way tags are denoted, they're like normal resource locations, but you put a little hashtag before them. And that's what they look like. Inside, at least, recipes, other tags, loot tables, you use that notation. And then, so here's what a tag definition actually looks like. They're JSON files in the data folder. So you can specify the values that are associated with the tag. And the name of the file is actually like what the tag is. Like most things in the data folder, the name is very important. And then, so you specify the values. You can make them optional by putting the required false thing there on the right. And you can include other tags by putting a hashtag tag name, like I mentioned last slide. There's the replace flag, which determines if you actually fully replace the tag itself by overwriting like a Minecraft one or another mod, or just add to it. And then the remove list, which just removes it if you're not overwriting. It can remove things from other tags. And then another concept in tags that's important is shared tags. So shared tags are useful because if Minecraft mods like add different types of content that does like the same thing, or they want interoperation between mods, they're really helpful. So like, for example, if you have tech mods and they all add like silver, like you have 3 mods and they all add silver, and you want your silver to work with every other mod's silver. So like if you had a recipe that used a silver ingot and you wanted to reference silver ingots, then you would create a tag for silver ingots, right? But if you put that in your namespace, like in your mod ID, then it would be difficult for other mods to reference it and add to it, because then they have to know every single mod that adds a namespace. So instead, you create a shared, like common tag namespace where different mods can add to it, and they don't have to like know all the other mods that are using things. And so in Minecraft, modern Minecraft mods, that's C, just the letter C is the namespace. So Fabric calls that conventional, but C, common, conventional, whatever you want. So you would have a tag like C silver _ ingot. That would be a real tag that exists somewhere. The naming isn't really standardized, so you might have to add it to multiple different like formats. So it might be in like ingots/silver rather than silver _ ingot. Fabric recommends you do silver _ ingot, but some mods don't listen to that. So if you look at the community list on the bottom there that I linked to the Fabric wiki, it lists basically every mod that it can find on GitHub and what tags it uses. So that's a really useful resource if you're looking for common tags. In the past, Forge also used the Forge tag namespace to fulfill this same problem. And even further in the past, there was a thing called OR dictionary, but we don't use that anymore because it doesn't exist. But if you hear about OR dictionary, it's the tag system before Minecraft had tags. Loot tables. So loot tables associate loot with stuff in the game. So for example, when an entity dies, it has drops. A block, when it's broken, has drops. When you open a dungeon chest, it has loot in it. When you fish, it spawns random items. Those are all using loot tables. So loot tables define what loot comes out of things. So they're weighted random in nature, meaning like you can define the like relative weight of different objects within the loot table and their chance of spawning. So you can also guarantee it by using different like loot pools. So yeah, they can create like a different amount of items in a certain range. So you can be like, I'm going to drop 2 to 3 steaks or something like that. And then they have a concept called functions, which add functionality. So like you could apply an enchantment using a function. You could handle smelting using a function. So like if an animal's on fire and it dies, there's a function that makes it drop the cooked version of the meat. That's a thing that exists in the game. So loot tables are broken into loot pools. And loot pools, like all the loot pools in a loot table will like execute basically. And then each of those loot pools has conditions and functions which change how it fires. And then inside the loot pools you have loot entries, which correspond to actual items. And those entries can also have conditions and functions. And they also have weights, which determine your relative chance. So loot table, loot pools, and then loot entries. A little complicated, but think about it. If you have a loot table for like a chicken, you have a loot pool for their feathers, and you have a loot pool for their meat. And then there's different chances of those things dropping. And then you have recipes. So recipes are not just crafting recipes, but they're also furnace smelting, stone cutter, and smithing table recipes. Not every recipe system in the game uses the recipe system. That sounds a little contradictory. Not everything uses the data system. So like brewing recipes don't use this. I don't know. Some other types of recipes probably don't use it. But those are the 4 things that use it. There's also like, I think in newer versions like archaeology pots or something use this. I don't know. So they map ingredients, experience, and fuel to a result. And there are different types of crafting recipes. You have shaped recipes, which have a specific pattern they have to be in. Shapeless recipes, which do not have a specific pattern, they're just ingredients. And then special ones, which do various things. So like when you combine 2 swords with different durabilities and it repairs it, that's a special type of recipe. Fireworks, armor dyeing, that sort of thing. And then a little bit on data generation. I'm not going to actually demo this yet, but I'm just going to talk about data generation. So say you had a mod and it has a large amount of content. It's very repetitive. So like if you have 5 new types of wood and every single wood had a plank, a log, a sign, a door, a staircase, slab, everything, right? Each of those would need recipes to craft to each other. They would need tags that associate them to like different wood planks, wood logs, and then like tying all of those together, adding loot tables for every single block. All that would be very, very cumbersome to write all the JSON definitions. And you could also probably make some mistakes copy pasting it. I know I've done it. So you can use your mod's code, like the actual code itself. You can write code that generates these JSON files from the like objects, the registry objects themselves. So then you don't have to associate it like arbitrarily. And then it generates the JSON files, writes them, caches them, and then puts them into the source generated resources folder, which is saved between like runs. So then you can ship that with your mod, and then every time you want to like update it, you rerun the data generation. So the way it works in most of the loaders is it adds a new like run configuration to your IDE. You might have seen it already. If you like look at, there's client, there's server, and then there's data. So data spins up a version of the game that's like minimized and only generates the data because it actually uses the game's code to generate it. And that concludes my presentation for today. This one is a little shorter, but we're gonna do a lot of stuff with blocks. We're gonna have so much fun with blocks, guys. Yippee! So, if you boot up your IntelliJ, we're gonna add some blocks. So, in terms of like what our block is gonna do, I want to experiment with making different models, making like an actual 3D model for a block, varying that based on its block state. We're gonna make some like fancy block state stuff, and we're gonna react to like actual things happening on the block. So like something I was thinking was like we make like a cannon, and the cannon only has like 3 fires or something, and that is stored in a block state, has different facing directions. I don't know, what are you guys thinking? You want to make a block that does something. Any ideas?
The cannon was fun.
You like the cannon? Okay. We like explosions here.
That's the same.
What's up?
A transparent rift that will pull entities towards it and consume them.
That requires kicking.
It does.
That means I have to make a block entity, which we are not doing today.
A metal pipe.
A metal pipe.
Just a metal
The
pipe.
block? As a block?
Yes.
That sounds pretty boring. It doesn't do anything.
The Mario pipe.
The Mario
Do
pipe.
waterlogging.
We could actually do... No, because those would have to be like tied to each other somehow.
Waterlogging metal pipe.
Yeah. All right. We're just going to start making something and see what happens. So we're just going to start by making our... So I actually like to put all my like mod whatever files into a package called init. So I would move mod items into there. Package, not folder. And then create a new class called mod blocks. And then mod blocks is going to be the same thing as mod items, but instead everything is item. So you change the deferred register type to block, and then you rename it to blocks. And you import the block class. The one thing I learned, actually, is that you can do deferred register dot create blocks, and then you don't have to specify the registry. You can just do the mod ID. There's also one for items, so you don't have to, for those specific common ones, they have a method that just creates it for you. All right, so that's basically just copy pasted from mod items, but and then you need to register it. So you do mod blocks dot register mod event bus inside your mods constructor. While we're here, we're also gonna remove this log message, because if you leave this in the final version of your mod, I'll cry. Because actually there's mods on CurseForge that have the hello from common setup from the example mod like in them. And I think it's really funny when they do that. But I also cringe. So we're gonna remove that. What? Okay, you know, that's fine. I like a funny startup message. In Better Analysts Plus, there's a bunch of like funny startup messages that are like over spawning Lammergeyers. That's a reference to version like 1.1 where we had the Lammergeyer mob. It spawned like 500 of them in the air. So your skies would just be filled with them flying around. It was a nightmare. So we had that as a little reference. Anyway, so now we have our mod blocks, which means that we can register blocks to it. So I'm also going to create a blocks package with our block in it. And we're gonna make I guess we're doing the canon. Sounds fun. So canon block. And then so your class should always extend block, obviously. Make sure it's the right block, not the JOrbis one. And then you have to add a constructor. So you do this. So now that we have our canon block, we can create an instance of it and register it. So we do public static final registry holder, or is it deferred holder? Yeah, deferred holder, canon block equals blocks dot register canon, and then you do new canon block, and then you pass it a list of properties. So that would be block behavior dot properties. You don't make a new one. You have to make the build. There's a builder for it. I think that's it. Yeah. I got these backwards. It's block, canon block. So the first one is the like general type that the registry is for. The second one is the specific type of the thing you're creating. That's important. What's up?
What's the difference between deferred block and deferred holder?
Oh. So deferred block is shorthand for what I just wrote. It's the same thing. If you actually open deferred block, right, if you go to, and then it's declaration, you'll see deferred block is literally extending deferred holder block. It's the same exact thing. It has a few more methods, it looks like. Like it has this as item thing, so that's nice. I guess we'll use deferred block then. Why not? What's up?
I'm getting an error in the first line. So like deferred register.
Hold on. Did I not like... Hold on. We're just going to look at the documentation real quick, because I am clearly mistaken. Huh. I see. So there's actually a different way to do this, which is the same thing but better. So you do canon block new, and then that. And then you pass it register. there's a deferred register dot blocks. So blocks have a bunch of weird registry crap, so I guess NeoForge is trying to make it easier by making like specific methods that help with it, but I'm honestly kind of annoyed. So this is the correct code to register a block. I'm just gonna put that on a new line so you can see it. There's a bunch of special types, so I mean you can do it the way I did. It's just this one is a little more supported, I guess. They're helpers. Now we should theoretically have a block in the game, which means we can use setBlock to actually place it. But there's not going to be any item that places it. Like, it's just going to not really exist in any creative tabs. So we're also going to create a block item, like I discussed in the lecture part. So if you didn't get that, that's okay. We'll go back to it. Also need a block item. I think there's also, while we're here in the items, there's probably a deferred register dot items. Yeah, there is. And you do create items. You remove this. And now you have a item registry thing. So now we can do replace that with a deferred item instead of a deferred holder. And it's the same thing. And then I think there's probably something like this where you can go ta-da. So that's the same thing we just did with the blocks where we change it to a fancy deferred register, but with the items. So for item blocks, I'd like to create a little separate section to make sure, like, show that these aren't actual items. Or, sorry, they're called block items. My brain is wired for MCP mappings, which they reverse the order, so the type would be first. So like entity pig. My brain is wired for that. So the correct one is block items. If I say item block, I mean block items. But so then we do public static final deferred item. And then this is a block item canon item. Or just canon, I guess. Then we do items.register simple block item. And then you provide it the holder for the block. So it'd be mod blocks.canon. So that will create an item that can place our block. Okay, so now that we have a block and an item, they're not going to have any language entries or models, so they're just going to show up as errors. And also our item's not in a tab. So first I'm going to add the item to a tab. I'm just going to throw it in tools, in utilities probably, since we already have that here and I don't really want to worry about it. So same way we did it for the other one, we're going to add it to a tab. And then we're going to create an item model. So most blocks use a model that corresponds basically directly to their, most block items use a model that corresponds directly to the block itself. So the item actually looks like the block. So we're just going to make one of those real quick. So the way we do that is just by adding a JSON file, canon.json, inside the item models. And then I think we're going to go steal code from my mod. As we do, because I can't remember for the life of me how to do this. Actually, I don't think there's any normal blocks in that one. We're going to steal it from Whisperwoods. So it goes in models, item, and then let's see. So this these ghost lights are actually, no, that's not right. We're going to look at Toad Terror, because that has actual blocks in it. Here it is. So you literally just pass it the model for the block. So like the canon item is just gonna be the same model as the block. So now our item has a model, as long as our block has a model. And then we're also going to create a language entry the same way you would for any other thing. So it's block.catmod.canon, and we're just going to name it canon. And I believe the item will inherit it from the block, the name. Not sure about that, but we'll see. And then now we get to create a model for the canon. So I'm going to open Blockbench. We get to see how Blockbench actually works today, guys. So we're going to do canon.
I think when you create it, do you want to just share it with everyone?
Sure, yes. So we have a canon and then 16 by 16. So I'm not a good modeler, so this is going to be, it's not going to be great, but if we just move this little cube to the middle. How about this, actually? It'll be on wheels, like an old little cannon. So we have 4 cubes on each corner. So the fun thing about these is you can actually make their textures overlap with other ones. I think if you do the UV mapping here. So I forget how to actually use this, but if you right, so this texture here has this is the canvas, right? And so you can specify where each face pulls its texture from on this canvas. So we want the north, we want each, like the top and the bottom, and then the north and the south ends of each of these wheels to have the same texture, and then the east and the west ends will have the like spoke texture of the wheel. So we can keep all of the north ones, south ones, west, up, down, or north, south, up, and down on the same like face, and then we move east for each of these cubes right there, and west right there. And then you can also click this, and I think it mirrors it. So then you can mirror it on the x-axis because like the wheels are like mirrored. So then you have. So then we just repeat this for all the cubes here, moving it, and then mirroring this one. And move, mirror, and move, mirror. So this is what I was talking about when I was doing like UV mapping. That's where you map the faces to an actual place on a flat texture. So now we have 4 wheels, and we want like we want a base, right? So we're gonna move this up, and then over, and then we're gonna flatten it using the scale tool. So now we have like a base for our thing, and actually I think I want the wheels to be like outset rather than inset. So that's our base for the cannon. And we can move the texture of this, like, over. We want the top and the bottom to have the same texture. And then the sides, we're going to rotate this. No. Is you turn it. That's what I'm thinking. And we need the sides to have the same, so we're just going to do so now I've made like basically unique space where these all get the same like location for their sides. I don't know if there's enough room on this canvas, so I might actually have to increase the size of it. To 32 by 16. Is that right? Hold on. That simplifies things. So this will automatically, like, UV mapping is hard. The projector just turned off, that's weird. So this is too big for it to fit, so we need to go 32 with 32.
The reason why I limited you at first is because, like,
I don't know, dude. UV mapping is really annoying.
just move the individual faces.
I don't know.
Just click on only one square on the UV map and then drag that square.
I have to change the mode for that to work. I'm not good at this. I don't do art. There. Okay. That's our UV mapping. I'm just going to save this as it is real quick. And then I'm just gonna, I really want to be done with this, so I'm gonna add a cube. This is the cannon. It's gonna be tiny. So like, yeah, we'll get there. Give me a sec. So this cube is the cannon, and you know it's the cannon because it looks like this. That's the cannon. I'm gonna keep this within the bounds of the block though. So this is our cannon, guys. It's really small. And then, so we're going to UV map this over here. Yes. Yes. Yes, graphic design is my passion. Rotate the mapping here. Turn mapping. Okay, so now we have all these cubes, right? Oops. So now we have all these cubes and we have a model. So we can export this model as a block item JSON model. And then we can also create a texture. So it would be cannon and it's gonna be a template. So then we can like actually texture this thing. So this is how it has UV mapped it. That's not what I did, but you know what? It's fine. It looks like it'll work. So you can see now that everything has its own like face color, and we can texture this thing.
Just put it in the game as is.
Yeah, I'm not actually going to texture this. That's too much effort. So this is going to be our texture for the cannon. So you'll notice I made the cannon facing in the north direction. That's very important because then when you actually turn the model using block state definitions, it'll like correspond. Because we're going to put facing directions on this. Okay. So now we have these two files, and we can actually import them into our mod. And I'm also going to post these on the Discord real quick. Now we go to source, main, resources, assets, cat mod, textures, and then we need to make a folder called block. And we're going to put canon.png inside. And then we go to models, make a folder called texture. Or not texture, block. My brain is processing. Put the JSON in there, right? So now they're going to be in our IDE. If we open models, block, here's canon. It says made with Blockbench. So see here it's defining which textures we're using. And then it has all the elements, which are our cubes, their faces, and those faces UV mappings, and the associated texture. So all in all, that's our model. Pretty small, but it works. And so this texture here is going to map. We need to actually change this to cat mod canon so that it like gets the correct texture from our namespace rather than doing relative, which would not go super well. So now that we have our cool model here, it's going to load based on the block's ID, which it's, well, no. So it doesn't load based on IDs like items do. You need to make a block state definition. So we make a directory called block_states, and then we make a JSON file that matches the ID of the item itself. So it's canon.json. So this file maps our block states to model variants. And that means you can also adjust the model based on its different states. So if we're going to have 4 different like states, like for each direction the canon can face, right? We need to map each of those 4 states to a model. And so they're all going to be the same model. They're going to be the canon model. But there's also a special directive where you can actually rotate the model based on its state. So we can actually rotate the canon 90 degrees to match its facing direction. But right now we don't have any of that. Like we don't have any states defined. So we're just going to put the 3D model, which I believe you just, yeah, like this. So this is what a block state definition for like a blank block that has no variance looks like. You put a variance definition and then you put the block state. And since we don't have a block state, it's just going to be empty. And you do cat mod, : and then the model you actually want. It's going to be block/canon. So that corresponds to this JSON file. And then, like before, this item model just also corresponds to the same like 3D model here. So we have all the models, the block state definitions, the item model, the texture, and then we also have a language entry. I added that here. So theoretically, our block, because we registered the block register, should be in the game. So we're going to boot it up. Alrighty, here we are in my mess of a testing world. So I put it into the Tools and Utilities tab, so it'll be at the very bottom here. Look who it is, guys. It's a canon, and the item model looks really stupid because it's not rotated. So notice most blocks have this rotation applied to them. The canon does not. And I think that's because we didn't define the displays properly. But so if I place this now, it doesn't have the, okay, well, that's a little sad. What I'm getting here is I didn't map the block state properly. So if I look in here, let's see. Missing textures in canon inventory. Textures, atlas, blocks, cat mod, canon. Exception loading block state definition. Cat mod, block states, canon.json. Missing a model for variant canon. Oh, see, this is why you read the documentation. So I named my folder wrong. It's not block_states, it's just block states. That's why it didn't work. And then also we're gonna go on Blockbench, and I'm gonna update the displays on this so that it shows in the inventory correctly. So you'll notice it looks really stupid in your hand. So we're just gonna do a little bit of work there to make it look correct when you're holding it. Yeah, Blockbench is really cool. It's good at what it does. I wish that you could just mirror these onto the other one instead of having to copy paste it. Like, huh? Yeah, it's a lot of work. I see it. That actually does look like it does what I want. So, yeah, that was nice. Thank you for that one. Good tip. And you have first person, so I'm gonna make it look like this. And then you have your head. You can actually wear items on your head, fun fact. I love that, actually. I have a cannon on my head. What's up, guys? On the ground, we're going to translate it up a bit because it's a little bit low, I think, in my opinion. That looks good to me. In an item frame.
Wow.
Yeah, so these are all the different like places a block can actually display its model. I'm not sure if I like that. Maybe. We'll rotate it. Like, oops. To the side, that's actually a good idea. Yeah, that looks a lot better. Yeah, you could do that, but I like this one, actually. And then GUI. So this is the important one. So there's actually a... There's a default one that all, like, blocks use. It just involves like doing a rotation. I think it's like 45 degrees here. And then also 45 here. I think it might be like 35 or something. I like this one. I think that looks pretty. I'm going to scale it down slightly. Oh, here it is. There's a preset for blocks. This is the one I'm looking for. Except I don't like the scale, so I'm going to do 0.8 instead. And then I'm going to move it up a little bit. Much better. So that looks like it should, in my opinion. Maybe a little bit larger. So now we can save the model again and copy the new displays from that into it. So if we open this JSON, then open our existing one. Nope, hold on. So you'll notice that the JSON, it just added these this display tag. So I'm just going to add that rather than replacing the whole file again. So now that we have a model and the right displays and it has the block state definition in the right folder, theoretically, it should render correctly. Moment of truth. Look at that. That's a cannon. So you'll notice that the ground underneath it is transparent. And that's because we didn't say that the block is like transparent. So like glass, for example, you can see through glass, but most blocks actually cull the shape underneath it so that you can see through. So because it doesn't want to render stuff that's underneath it. You don't see this dirt block. So we have to actually add culling definitions, which I forgot to do. So the way you do that, I believe Blockbench also has a thing for that. You can do like face calling. Yeah, set call faces. There should be like a different thing for it to do it like manually. Yeah, I don't know how to do it, so I'm gonna do this. Which should set the culling to based on the actual shape of the model. And then if I save that and we open it again in VS Code here, we're gonna see what changes it made. Here, so no, I don't think that's right. So the cull faces are different. So the individual cubes inside the model, if they're like touching each other and you can never see one of them, it doesn't render that face. So for example, if you look at this Blockbench model, you'll see that the wheels are always touching the ground. So this would be a cull face down for each of the wheel shapes. And then this right here, see how this is always touching this cube? You literally never see the bottom side of it. The cull face for the bottom of this would be down. So then you would never see it. Well, actually you can see the front half of it, so that's not true necessarily. You can see the front of the bottom here. But that's what a cull face is, and that's what it added here. So you can see all the wheels have a cull face of down, and then this one has a cull face of north, which means that if there's a block directly north of it, you won't see the front because it's touching the front edge. So I'm actually gonna update the model here to match that. You guys don't need to do that. I'll post a new one eventually. Yeah, so Minecraft JSON models are pretty complicated. The other thing, I believe the thing that actually changes if it's transparent or not is you do the render shape, is it? No occlusion. That's the one. That's the attribute. It's if we go to mod blocks and we put .no occlusion, that will disable the process by which it hides stuff behind it. That's what occlusion means. So now we can see through it. So now we'll see that we are not hiding the block underneath anymore. Hooray! You also notice how this block is darkening things around it. That is called ambient occlusion. See how it gets a little bit darker? So if you actually go to your video settings and turn off ambient occlusion, you'll notice the difference. Wherever it is. I think if you change it to fast, it disables ambient occlusion. Or not. If you change the lighting also to smooth lighting off. Yeah, no more ambient occlusion. So we want it to look like this, where it doesn't actually darken everything around it. Oh god. So there is a field in the model also that controls this. They really are making us put in the work, but if you do false, I think, hold on. Yeah, just like that. Ambient occlusion false. It will disable the ambient occlusion, which will make it not do that. We can maybe hope that reloading the textures with F3T will fix it, but probably not. No. So now we have our cannon. The texture isn't loading, which is kind of weird. So I must have made a mistake there. We're gonna look at that. Missing textures, cat mod cannon. I think it's probably cat mod block cannon, maybe? Also do inventory. Yeah, it is. You need the block in there as well. I don't think you need the inventory one, because if you look at the item models for the Wisp lanterns, actually we use a 2D one, so it doesn't matter. But yeah, it's the hanging. So Wisp lantern orange, purple hanging. we don't have an inventory model. So we just do it like that instead and boot up the game. Now it'll work. Don't need this though. Ta-da! Why is it still doing ambient occlusion? This is very annoying. Stop it. So that's how you actually disable it. Yeah, it's off right there. Who knows? So those are our cannons. They currently don't do anything. And also see how the voxel shape is really tall? So we can override the getShape method and change the shape, but I don't know if I want to do that yet. We're going to work on the face first. So see how like grass has a different hitbox than the full-size block? That is the voxel shape. So you'll see now, look at her. Beautiful. Looks perfect. And you'll notice no matter which way I face, they always face north. So that's no fun. It's an interesting discovery. So now we are going to add block states to our cannon so that it can actually change state based on which way you are facing. So the way to do this is by overriding the create block state definition method. So by default, this is totally empty, so you don't need this super definition, but it gives you this builder. So the builder, you can do add and then a property, I believe, or is that how it works? Hold on, you have add and create. Yeah, you want add. So now you can add properties. So there's some shared properties, I think. Block state properties has them, and the main one is facing. So this is for like up and down are included in this. We want horizontal facing because the cannon can only face different horizontal directions. So you actually go look at the definition of this. It's direction property.create facing, and it has horizontal. And then direction properties are look like this. So it's just a type of enum property for the direction field. So you can make crazy like properties that have different values. But right now we just want direction property. And while we're here, we can also do builder.add block state properties .waterlogged. So now we've added waterlogging as a valid state. So that should get us most of what we need. And then I believe the block item has to actually somehow factor in the facing. The horizontal direction is a pretty common one, so I think they're actually probably already a built-in way to do this. It might even automatically do it, I'm not sure. So now that we added block states to it, we actually have to add variants. So if I look at the block state definition for these wisp lanterns that I have, you'll see that this is what the variants look like. Facing down, horizontal, north, that sort of thing. And then waterlogging is also here. So all we have to do is add one for every single like possible entry. I think you can also put a default, and then it'll just use it for all the other variants. The thing is, we do need to rotate it. So if you look, so these Wisp lanterns, they use block models. They have these. You can change the Y, which does a Y rotation on the variant. So what I'm gonna do is I'm gonna copy this. Yeah, I'm not going to do that. So we have facing equals north. I'm going to do nothing. And then we have facing equals north, waterlogged equals false. We're going to copy this. For each of the 4 facings, we're going to do north, east, west, south, or I'm just going to do it in order. So then you have all those, and then we need to copy this again for each of the waterlogged. So you'll see how this can get very out of hand very quickly. But so our block has a total of 8 unique states, 4 facings, waterlogged, yes or no. And then we also need to rotate it for each of these. So we have Y for east would be 90 probably. And then Y for south is 180. Y for west is 270. We're just going to copy this. Update the waterlogged again. And that's our block state definition. So now that will associate the block states with models and perform the rotation. And then, yeah, I think that should do it. So if we boot up the game, we're going to hope that our block item will actually place them in the different states, but it also might not. Alrighty, so now we have our 4 block states. The block item is not doing what we want, so that's cool. But if we put this under water, it should get waterlogged now. Okay, well that's not very helpful. I think the problem here is that it doesn't have a like voxel shape, maybe, that fits it. Is that true? Hold on. So if I put a water bucket on it. Oh yeah, there's an interface that adds waterlogging functionality to the block itself. I forgot. If you open the, yeah, you need to implement the simple waterlogged block, and then that adds the waterloggability to it. You might also need to change the. That's no fun. Here it is. Yeah, you need this update shape thing. And then you need to update the fluid state. I see. Yeah. Blocks are so annoying. That's why I'm not a big block person. But so if we go to our cannon block and we implement simple water logged block, it's gonna first tell the game that we want to be waterlogged. And we also need to override the get fluid state. And we will base that based on we check state.get value for block state properties dot waterlogged. And if it is waterlogged, we can do fluid state dot water. Is that, hold on. Fluids dot water. Okay. I need my computer to be quiet. Okay. Fluids.water. Nope, that's not the right one. There we go. Otherwise, we do super.getFluidState. So that's how we add the water loggability to it. We also need to make sure that when it has a neighbor update, like water-wise, it receives the updates. So if we override getShape, what getShape does is, not that one. That's not the one I wanted. DateShape, not getShape. So what updateShape does is it receives block updates from neighbors. So say that a water flowed onto this thing, we check if it's waterlogged, and then we spread water if we are waterlogged. Schedule tick for they must have changed how this works. What's a waterloggable block? Fences. Yeah, I'm kind of annoyed right now with this thing.
Not that big, but definitely newer than Culling.
Here it is. You copy this bit of code. There we go. Does this one also have the get fluid state? I don't see that. Yeah, okay, cross collision block implements it. So that means that, yeah, here's the get fluid state. So same thing I was doing. So if we want a block that has 4 facings, we can just steal code from it. What's a block that has 4 different facing directions? Not signs, those have too many. Doors? Doors have different facing directions. Yeah. So if you open the door, we'll see that doors have a facing. We want to mess with their facing. So the important part is we need to, for it to like place with the correct item block, the way the item block determines which state to place is through the getStateForPlacement method. So we need to override that in our class and then define which state should be placed. So if we do at override getStateForPlacement, we can return blockStateProperties.horizontal facing and then return the horizontal direction from the context. So that should do it. We also need to define our default state, which would be this dot set default state. No. Properties dot set. What? Oh. Hold on. Register default state. That's great. This dot register default state. And we're going to do set it to not waterlogged. And we're going to do facing horizontal facing is direction dot north. So now we should properly react to being waterlogged through these two methods here, and then also implementing the waterlogged block. And then our actual facing direction will change based on when we place, because it checks the horizontal direction from the placing context. And we have our facing definition here. I think that's everything we should need for facing to work. We can also change the shape, but I'm not going to do that yet. So now, close this. We now have a block that is waterlogged. Look at that. So if I place this, it's facing in the correct direction. So these actually have different states. And now I can waterlog it too. So if I use a bucket on it also, look at that. And if I place it underwater, it gets waterlogged. I guess not immediately. Not sure how that works. But it is waterloggable. And then, yeah, I don't think this part's working properly because it's supposed to actually spread water. I think that's probably why it's not placing with the right waterlogging value. So if we go to our waterlog, get state for placement. Yeah, so when we actually get the state for placement, we also need to set the waterlogged. Fluid state would be this. So if the current fluid state of the position we click on is water, then it sets it to be waterlogged when you place it. So there we go. Now we have a waterlogged block that faces different directions and it rotates correctly to match. Pretty good. I don't know why it's still ambient occluding. It really shouldn't be doing that. So our block doesn't actually do anything. Fun thing, actually, if you give yourself the debug stick, you can mess with block states. It's a special Minecraft item. So this edits the block states when you right-click on stuff with it. And you can change which ones it uses by clicking. So this is a really good way to experiment with block states. So you'll see that's south. Does that match? Yes, that's south. It's west, east, north. So you can do this with basically any block. Like, look at that. Let's see, can I do that? Oh, look at that. I made it into upper grass. Kelp. I'm just making this kelp very old. I think you can also reverse by doing shift. Yeah, if you shift, it changes the state backwards. Anyway, so that's fun. I'm gonna de-waterlog these real quick. So now if we want to make it actually do something, like fire, we can add a right-click response for our cannon. So if we do override, and then use without item, right? Or do we want it to require like fuel? We could do that. We could like, you have to give it like TNTs and it shoots them maybe.
Use without it, because I want to right click it.
You just wanna shoot stuff? Okay. Yeah, that's fun. We'll do that. So if the player right clicks on it, then we are going to do since it always works, we're going to do interaction result dot success, no item used. Yeah. And then so that just means that your hand will like make a visible animation when you right click on it. And then it's going to do first we do state, because that's the current block state, and then we get the value for the block state properties dot facing, horizontal facing, right? So that gives us the direction that the block is currently facing. And then we can offset from our current position based on that, and then trigger an explosion there. So if we do so we know the position is posed, we can do offset. I think the direction actually does that. Facing direction dot offset. That's great. Thank you, computer. No. Relative. They renamed it, so it's not offsets. So you do facing direction, and then how far do we want to shoot? Should 10 blocks? Why not?
Yeah.
Just 10. So we do. So if you think about it, that's always going to do 10 blocks away. So I want to introduce the concept of ray tracing. So instead of going exactly 10 blocks away every single time and putting an explosion there, we first find if there's any blocks within the 10 block route directly ahead of it. And then if there is one, we trigger the explosion at that block instead of 10 blocks away. So if we do we can do normally you could do like a proper ray trace, which tries to find a block in the path, but instead what I'm going to do is I'm just going to iterate between the two. So if we do, so we're going to iterate for every block in the range of 1 to the maximum distance, which is 10, or I guess 11. So that's for every distance. We are then going to check if there is a block at that offset by doing level.getBlockState at target position dot is air, right? So if it is not air, then we are going to break, and I'm actually going to put the target position out here, right? So then it exists outside of the context of this loop. So as soon as it's air, it'll stop continuing over these 11 blocks in that direction. And then you have a block there. And then we can do level.explode from null at target position. Get X, get Y, get Z with a range of 4 and an explosion interaction of TNT. What is this? Oh. There. So now it will go through all the blocks in that direction up to 10 blocks until it reaches one that isn't air or reaches the end, and then explodes at that position when you right click on it without an item. So theoretically, our block will do a thing now that changes based on its state. One more thing. So blocks actually determine their drops based on loot tables. They don't drop anything unless you have a loot table. So we need to make our loot table for our block, or else when you break it, nothing will happen. So if we go to data, loot tables, blocks, and then look at the like lanterns here, you'll see that they have a pool that just drops the correct item. And because our cannon is explosive, we're going to make sure that it survives explosion. So if you go to, we actually don't have any data yet, which is interesting. So if we make a new folder called data, and then folder with your mod ID, and then a folder which is loot table, not loot tables anymore, it's loot table now, and then block, and then finally cannon. We're just gonna copy paste this in there. We're gonna drop a cat mod cannon. And we've also made sure that it survives the explosion. I think that this actually might make it actually respect an explosion, but we'll see. So now we have a loot table, which means our block will actually drop an item. Which is kind of important. And so, yeah, I mentioned loot tables, but this is what one actually looks like. So you have a type, your pools, and then this is a pool definition. How many times this pool rolls. So we only want the pool to execute once. The entries, so it can choose between these. They can have different weights. And then any conditions, which affect how it acts. All right, can we not do this? Minecraft, you're ruining my day. Anyway, all right. So now that we have our funny cannon, we're gonna place it.
Let's not change what we did to delete brain.
Boom! It works. So if I place now, if I go like here, right, and you'll notice that there's stone right there. So if I didn't program it, it would explode like underneath. But now it's gonna explode right there on that stone. And it broke the cannon. But you'll see it's actually exploding on the nearest one.
That's awesome. Make it like instead of just 11, it can be like 100.
100 is a bit far.
Yay.
So at that point, you actually have to start worrying about the chunks like being loaded. Like it might not actually be loaded at that distance, so you have to make sure that the block state you retrieve here, if I do get block state, this could be null. So if it's like, maybe, are these null? I don't think block states are actually nullable. I think you have to do like, I don't know. Something else is, I just check if it's air, but you'll notice like grass and stuff. Do you want to explode when you shoot at grass? Like, do you want the grass to explode? No. That's a little silly in my opinion. So I could also do, if it's not air and it's not replaceable, so like do block state at pos equals, right? So if position not air and can be replaced, right? So now if it can be replaced, or it's like, or if it, how about instead, what makes more sense is if it has collisions.
Just grass. Oh, I see. This player doesn't fly.
Yeah. Although I don't know actually how to check. See, but that doesn't work for like, because like a slab is still solid, right? So we want to instead check if the collision shape is empty, I think. Yeah, here it is empty. So if we get the collision shape at the position, is it empty? As long as it's not empty, then we can continue going past it.
That's not like a hot reload, so you don't.
Yes, but I haven't set it up. You have to do some stuff with the JetBrains like IDE. You have to install a custom like JDK that can be hot reloaded. I mean, you can also do, some methods can actually be hot reloaded like by default, but you have to be in debug mode, and I'm not in debug mode. So I really don't like that the cannon is not explosive resistant, so we can actually change that by going to mod blocks and then doing explosion resistance, and then I think like 4. Hold on. Yeah, so there's a blast resistance property, and it varies. It looks like something like obsidian has a blast resistance of 1200. So that's what we're gonna do. I don't know what the number actually means. Let's see.
Interesting they put so many different kinds of blast resistance, but only one, right?
Yeah, I don't actually know what blast resistance really means. If the block isn't air, the intensity is altered by the blast. I think, yeah, Minecraft explosions are like a bunch of rays that are traced, and so a high blast resistance means that explosions are less likely to pass through it, I think. What?
It also means that a really high intensity explosion using the vanilla explosion method creates really, really long chains of rays to the ground instead of the circle you expect.
That's why.
Yeah. This is so fun. We're gonna turn up the range. So now our cannon has a range of, here, we can do something like this. Public static final float, or I guess int explode range, or fire range equals 100. We can do fire range. There you go. So now, if we run it again, we will have a big range. Sorry that today's lesson is like a little more boring. It's more technical. Minecraft is complicated.
I wouldn't say boring, but more things that need to be done. Like, I just
Yeah.
gotta-
It's very heavy in like stuff that's not very like obvious, because blocks are really complicated, to be honest. Like, they seem like they're a kind of simple part of the game, but they're pretty complex. So now we'll see our cannon is going pretty far away, except leaves are sort of resistant to blast. That's 100 blocks, I think. So now if I put this underground, right? First of all, we're immune to explosions now, so that's good. So now we're just gonna dig a tunnel. This is so fun. So now we can go in our tunnel. Wow. It's so far. Great creation. So now we can dig it this way. And then we also need our exploding stick. We really like explosions in this family.
Oh, of course, though. You should have added. Well,
This could ray trace, so this could actually like do a ray to whatever you're looking at and then trigger an explosion there instead of just being a block that you right click on.
The cannon could be redstoneable.
Huh?
When you send in a redstone stick.
You think a lever should make this like fire?
Yeah.
That could be interesting.
Or, and then you can attach repeaters to it. And then slime blocks.
That could be a fun addition if you wanted to add that. I'm probably not going to do that, but you think you can move the cannon with a slime block? That would be fun.
Oh, I'm sure. I'm sure by
Let's try it.
It can be really
It can. That's awesome.
And so then you can attach a flying machine to it. And then
Yeah. But the problem is it only goes horizontal. It can't go like down or at angles.
No, it's on a flying machine.
That's aiming.
That's aiming forward and it's flying forward.
So infinite tunnel.
Infinite tunnel.
I see, like a cave. But okay, that's pretty cool. I like that idea. Oh, see, the debug stick is overriding its. There. This is so stupid. I love it. See that tree? I don't like that tree. Oh, I missed. Oh, man. Hold on. I'm gonna hit the tree. Be gone, tree. Anyway, oh yeah, I also added a loot table for this now, which means if we go in survival and we break it, oh, it didn't drop anything. That's no fun. Do you have to associate the loot tables with blocks? I think you might. Hold on. Oh, okay. It goes in blocks, not block. There. So now our loot table will work. Boom. That's kind of large. Oh. So, yeah, I think that actually concludes everything I wanted to go over today. So I'm going to end the recording. You guys have any questions you want to ask on the recording first? No? Okay.